In this video, we're going to do 8 examples of factoring trinomials with a not equal to 1. So if you'd like to practice, I encourage you to pause the video and try it out now. Otherwise, we're going to continue with 1a. So in 1a, it says 2x squared plus 7x plus 6. So here's how I would think about it. I'll think, okay, I know there's two factors. I know that it's something times x plus some number times something times x plus some number. I also know that these two have to multiply to x squared, and these two have to multiply to 6. So to figure out what those actually are, we're going to write down some possibilities for how those can be broken down. So for 2x squared, well, 2 you can think about the factors, that's 1 times 2, and that's about it. For 6, you could think about 1 and 6, 2 and 3, and that's about it. So basically what we're going to do is guess and check. So we're going to write down some factors, and we're going to see if that actually works. So our first guess is going to be x and 2x for these x terms, and 1 and 6 for our constants. So how do you check this? Well, you expand it, and you'll notice that when you expand it, these two are going to multiply to 2x and 6x. So currently we would get 8x. That is actually that's not what we want. We wanted 7, which means this is not the correct factorization. Let's try another one. Let's keep the x and 2x because we don't have too much choice there. And for example, we could try it the other way. We could say, what if we swap the 6 and the 1? Where do we want to get that? Well, we have 12x from 6 times 2x and 1x from x times 1. Together, that's 13x. Also not what we wanted. We wanted 7x, so this one doesn't work. Let's try something different. So we should still keep x and 2x because that's our only choice for 2. But let's now consider that 6 could be 2 times 3. Let's try 2 and 3 in this order. So this is, so if you look at the middle terms, it's going to be 2 times 2x, which is 4x, x times 3, which is 3x. That does add to 7x. So that means that this is the correct factorization. Okay, let's keep going. So the next one, you have 2k squared plus 3k plus 1. Same idea. We're going to break up this one into something, let's say 1 and 2, 1 times 2. And we're going to break up the constant into a product, let's say 1 times 1. That's really the only choice you have here. Then we're going to write down a guess for the factors. So we know 2k squared should come from 2k times k. You know that 1 should come from 1 times 1. And then to check our answers, okay, this one's 1k, this one's 2k. That does add up to 3k, which is the middle term. So that means this is correct. We got lucky there. That one's not that many choices to check. Okay, number 2. 2a, we have 5x squared minus 7x plus 2. Again, we need to think about breaking this up into a product. In this case, 5 is just 1 times 5. And then 2 is going to be a problem. That's 1 times 2. And again, we're going to do guess and check. So we're going to write our two factors. 5x squared comes from 5x times x. And 2 comes from 1 times 2. If we check these, you'll see this is 1x and 10x. That gives us 11x. That is not what we wanted, so that can't be correct. Now, don't forget that you can still swap how they're paired and see if that works. So you have 5x times x. And what if we swap the 2 and the 1? Well, you have 2x and 5x. So that's 5. So together that's 7x. That's positive 7x though. But we want a negative. So in that case, we're going to try again, but let's remember that positive 2 can also result from negative 1 times negative 2. If you switch the signs, you'll find that that works. Okay, so here's our new guess. All we've done is swap the signs for the factors of 2. We get negative 2x. You get negative 5x. Together that makes negative 7x, so this is now correct. Okay, let's do another one. So 2d, we want to factor 2x squared minus 11x plus 15. Again, we're going to break these up into factors. So 2 could be 1 times 2. 15 could be 1 times 15 or 3 times 5. Now you may notice that the middle term is negative. So let's also add negative 1 and negative 15 to the list and negative 3 and negative 5 as potential factorizations of 15. Now for a guess and check, so 2x squared could come from 1x times 2x, and 15 could come from 1 times 15. Now, if we do that, you'll notice that you get quite large numbers, right? You're going to see 2x and 15x that becomes 17x. So that's not the one, okay? If you try it the other way, with swapping the 15 and 1, you get an even bigger number. That's like 30x plus 1x is 31x. That's also not it. So we can rule out 1 and 15. What about 3 and 5? Okay, let's try. So we're going to keep the x and 2x for 2x squared. We're going to have 3 and 5, maybe like that. And we're going to see, okay, so this is 6x. This one is 5x. Together that's positive 11x. So it's almost there, but not quite. We're going to use the same trick as last time, which is you're going to swap the signs, because negative 3 times negative 5 still makes positive 15. So now you can check this, negative 6x, negative 5x, that gives you negative 11x. This one is the correct factorization. Okay, let's continue with 3a. So we're looking at 3t squared plus 7t minus 6, and we're trying to factor this. So we're going to, again, decompose these into our factorizations. So 3 could be 1 times 3. 6 could be 1 times 6 or 2 times 3. Now, because it's negative 6, remember that positive times negative gives you negative. So one of these got to be negative. could be 1 times negative 6, 2 times negative 3, or maybe the other way around. Maybe negative 1 and positive 6, and negative 2 and positive 3. So now let's start guessing and checking. We have t and 3t. And let's try out 1 and negative 6. So we're going to check the middle term now. This is 3t. This product is negative 6t. That is negative 3t. So that's actually not what we wanted. If you switch the signs to negative 1 and 6, it just gives you positive 3t, so that's also not what you want. Now, you could also try it the other way. You could try, what about negative 6 and positive 1? You switch the locations. So you're going to think about this product is negative 18t. This product is 1t. That's going to give us negative 17t. Also not what we wanted. So any combination of 1, 3, and 1, 6 is not going to work. Now let's try 2 and negative 3. So you'll notice you get 6t and negative 3t. This, you get positive 3t, so that's not what you wanted. Let's try it the other way now. What about negative 3 and positive 2 instead? Well, we're going to get negative 9t and positive 2t, so together that is negative 7t. That is almost correct. So let's notice that if we swap the signs, so we get negative 3 and positive 3 and negative 2, then these middle term signs are going to switch. So you're going to get positive 7t, which is correct. So that's our final factorization. Let's keep going. So 3d, we're trying to factor 4m squared plus 3m minus 10. Again, we're going to decompose 4 and 10 into its factors. So 1 and 4, 2 and 2, those are the ways you can make 4. And then 10 could be 1 and 10, 2 and 5. Now remember, negative 10 could be 1 times negative 10, 2 times negative 5, negative 1 times 10, or negative 2 times 5. So we do have some more choices that we might need to test. Let's try them out. So we have 1m, or just m, times 4m, and then 1 and negative 10. If we check the middle terms now, you get 4m and negative 10m, so it's like negative 6m. Not what you wanted, so let's try something different. Let's think about, could you switch the 1 and the 10? Would that help? So negative 10 here and positive 1 here. Well, you'll see that's negative 40m, quite a big number, and 1m, so this is even worse. It's negative 39m, so we're not really going in the right direction. Let's try the other combination now with 2 and 5. So 1m, 4m, and then 2 and negative 5. So we have 2 times 4, which is 8m. 1 times negative 1m times 5, which is negative 5m. That is equal to 3m. So that's our correct factorization. Moving on to example 4a. We're trying to factor 5a squared minus 7a minus 6. We're going to try to decompose these again into its factors. So 5 could be 1 times 5, 6 could be 1 times 6, or 2 times 3. But it's negative, so it could be 1 and negative 6, 2 and negative 3, negative 1 times positive 6, negative 2 times positive 3. Now let's start guessing and checking. So we're going to get 1a times 5a. And let's try 1 and negative 6. So let's check the middle term. You get 5a and negative 30a. But nope, negative 6a. Together that makes negative a. That's not the same as negative 7a, so we're going to try something different. If you swap the negative 6 and the 1, what do you get? You get negative 30a and 1a. That's going to be negative 29a. Also not what you wanted, so we're going to try something different. Let's try 2 and negative 3. We're going to have 10a and negative 3a. That's 7a. That's almost correct. The sign is just not quite right. So let's try it again with different signs. So negative 2 and positive 3. We're going to get negative 10a and 3a. Together that makes negative 7a. I should stop putting equal signs here. You get negative 7a, and that is what you want, so this is correct. Okay, last example for this video. We're going to try 4k squared minus 9k minus 9. So again, we're going to try decomposing this. 4 could be 1 times 4 or 2 times 2. 9 could be 1 times 9 or 3 times 3. But one of the numbers has to be negative because it's negative 9. So 1 times negative 9, 3 times negative 3, or possibly negative 1 times 9. Note that if you swap the signs on 3 and negative 3, you get the same thing. So let's try out, for 4k squared, let's try out k and 4k. Then for negative 9, let's try 1 and negative 9. We have 4k and negative 9k, which together makes negative 5k. Not what we wanted, so let's try something different. If we try swapping the order, you're going to get negative 9 times 4k, which is negative 36k, and then k, together it's negative 35k. Again, not what we wanted. Let's try something different. Let's try it with the 3's. So 4k and 4k, 3 and negative 3. So here we're going to get 12k. Here we're going to get negative 3k. Together that's positive 9k, which is almost correct, except the signs are wrong. So let's try it again, but let's switch the signs. You'll see that gives you negative 12k and 3k. Together it gives you negative 9k. So therefore, this factorization is correct. That's all for this video. Just a general comment, which is that this is always going to be guess and check. So it's important to practice so that you can do it reasonably reasonably quickly.